Hello everyone. Yes, welcome back to our robotic course. Yes, it's been a while. Life is never easy. Always have work and other stuff to do, but we are back. And today we have to get a rabbit ready. So, let's get into it. So today, what does it talk about? A bunch of stuff, like normally it does, and talks about how the machine that makes silk wool inspired the first computer. It also talks about the chess computer, the chess playing computer. Okay. Deep Blue, it's a supercomputer created by IBM. That's won the world champion Garry Kasparov. It talks about hardware and software by Charles and Ada. Got some weird looking dolls. Analytic machine. So we're starting to get more and more into the evolution, okay, of robots and getting more into the computer. This was also another story. So it mixes a bit of old stories, new stories. You can actually read the magazine online if you want. I don't know if they have in English. Probably it will translate automatically with the computer. So that's why it's much easier, because this is all in Portuguese. The first AI in 1966 in the University of Stanford. It says it's a robot that was capable to learn. Very good. And his name was Shaky. Okay. Got a bit of a shadow going on always, when you film it indoors or sometimes outdoors. That's why lighting is very important. Actually gonna have to stay without doing some videos for this week because having problems with the phone. Still don't know if I'm gonna get a new phone with a much better camera or get this one fixed. This one is gonna get fixed anyways, but I don't know if I should get a camera or just get a better phone with a better camera. We will see. The phone comes in handy because I can just do the videos and the whole thing on the phone, But I'm gonna do my best. If I see it takes too long, I'll just get a new phone and keep this one for backup to make videos so that I have extra storage, So yes, all for you guys. Here it talks already about generator, all type of generators. Although now you don't use it much, only in cases where there is no electricity, and a lot of countries that have problems with electricity, like in Africa, for example, they use a lot of generators because they have a lack of energy supply. And now with all the electric cars, we will have grid problems. So let's see what happens. Alternators. Just generators to give us a light, for example on the bicycles, alternators for the cars, so it keeps on giving us the energy feedback we need for the car to keep on going. And then we have an experience. Yuppie. Yes, I know everyone loves this experience. I do too. Okay, so let's get to it. Now the first one says, so we need water and a foil cup, and let's get it. Okay, got our paper because I don't want to wet the table, and there you go, our water in our Tupperware, which Tupperware has gone. Unfortunately, whoever liked Tupperware, he's not gonna have problems with Tupperware because they are over. It's happening a lot in companies, unfortunately, nowadays. So we got that ready. We also need a magnet. Okay, so I already prepared here a magnet. I'm going to use this one right here because we are going to do also this one here. Faraday's law. Faraday's law describes the magnitude of an electromotive force, or EMF. Okay, for example, let's look at this drawing right here. Or voltage induced or generated in a conductor due to electromagnetic induction, changing magnetic fields. That's why I have this drawing right here. So by passing this magnet through the copper coil, it will actually generate, okay, if I go from right to left, it will generate a negative, or left to right a positive, okay, depending on which way you're turning around everything, right? So let's say in this case you go left, this will give us a negative. The experience we're going to be doing will be giving us in millivolts, and from left to right will give us a positive current, okay, voltage, sorry, not current, voltage, which can also turn into current, but anyways. It also gives us the electric magnetic force, and that's what we're going to see right here. By turning the magnet left, or turning it, or rotating it right or left, it will turn the copper cap foil also left or right, and we will see that in real action. Then we'll just have our robot, which we already have mounted up, okay, so that doesn't stay boring, the video, and our programming, okay, yes. So on our programming, we actually going to make him do some more interesting things. It's already all pre-programmed. I've done it already, again, so that we do not take too long on this video. And our bunny robot, which is also already mounted up. Okay, so probably just do already the experience, and then we'll go to the programming and then the rabbits in the end for fun. Okie dokie, let's go. So first let's take our amp meter and choose the option millivolts, okay, not milli, just not said mini. At least I know the mistakes I do. I'm also going to just show you here on a paper what Faraday's law is, just so that you can get like a, okay, it's easy, like there. You can just like screenshot that if you want. Okie dokie. That's the like important part, just so you know what it's all about. And you also got the formula in case you really want to see the formula. Okay. And now we'll take our coil, okay, right here. So in this is a insulation tape, a plastic rod, okay, that are made so that we can put a copper wire and make a coil out of it, okay. And we got the two extremities right here. So normally I would apply voltage, okay, onto this coil, pass a reed, and the reed has like a switch with the electromagnetic field. It switches on and off, okay. In this case, we're going to measure the millivolts we get from passing a magnet inside, okay. So just get this ready. Okie dokie, so we are ready. Now as you can see right here, okay, you're going to see here the values. So I put the magnets on this rod, which is a file, okay. And it's magnetizing the steel on the file, okay. So by passing it inside and outside, inside, you see, it gave me very quickly a positive voltage. When I pull it out, okay, no, actually when I put it in, it gives me negative. When I pull it out, it gives me positive, okay. So I'm going to hold the button so you can see the value because it's quite quick. So just look here, 130 minus 130 millivolts, and now on the way out, 158 positive millivolts, okay. So now I'm actually going to hold when I'm doing this. Let me see if I can. Not going to be easy. Okie dokie. I'll probably go like that. Yes. Okay, so I'm going to insert it, and okay, that wasn't the one I wanted to do, but anyways, it's hold button is here. Okay, let's go. See there, it gives more, just depends how quick I am with the finger. So 96.7 millivolts DC, remember DC, by pulling the magnets out. Now we're going to do it by inserting the magnets in the coil, and 1 2 3. Okay, wait. Okay, come on, has to be forced. Oh, the hold, why isn't it holding? Oh, I really have to press it properly, sorry. Here we go. Okay, that was trying to make this work. Okay, too fast, too quick. Okay, minus 19, but of course it goes more. Just depends on with the pinky it's not working. Okay, let's see if I can do it now. Okay, 1 2 3, 1 2 3. There you go, minus 133.6 millivolts DC. Okay. Problem is that if I do it slowly, I don't think you can see it. See? So if I go faster in and out, it actually gives a even electromagnetic field force even stronger. So that's why it increases the value, see? If I go like with that speed, if I go very slow, it will give me 56, positive minus 80, positive 112. You see, so it all depends on how quick I go. I can't go too fast because it won't make, it actually does make a big difference, yes. And I'm just giving magnetizing this, okay. So if this was even stronger, to show us even more. So yes, so that's how Faraday's law works, okay. So we could do that experience in real. Very good. How Faraday's law works. So Faraday's laws described the magnitude of electromotive force, or EMF, or voltage induced generated in a conductor due to electromagnetic induction, changing magnetic fields, okay, through a coil will give us a value in millivolts. Let's go. 1 2 3. Minus 100 millivolts. Minus 143, and on the way out, positive 192 millivolts. So you can generate voltage by introducing electromagnetic field inside a coil. Faraday's law. How to create a millivoltage, in this case using a electromagnetic field through a coil. If I insert this rod, it will give us minus millivolts. If I take it out, it gives us positive millivolts. Minus 44, positive 65. Faraday's law. Okay, so now we're going to do the second experience, turning the foil cup using a electromagnetic force field using a magnet. Okay, here it shows us a round one, but I only have these two, so they're facing the same side here so that they don't attract to one another, and it actually gives us a parallel electromagnetic force right there. So the foil cup is aluminium and it's not attracted by the magnets, so it's just creating a force inside. So if I go right, it will turn right, and if I go left, it will start turning left. With one hand, not an easy task. Okay, oh man. Okay, so if I start turning left, the foil cup will go left, and if I start turning right, I don't even have to go fast. It starts to slow down and then turns into the opposite direction. Now, of course, the faster I go, I guess it will even work faster, but I'm just holding it with one hand. And then it also starts to want to hit against the Tupperware barrier. Now it's turning left. And it's not the wind, because this isn't making any wind. Okay. It's just the electromagnetic force. See? Oh, in the water it went. So it doesn't do enough. It doesn't make wind even to move the water or anything. Okay. So I'll put that in the middle, and I'll go very slow this time, just so that you can see that it is the magnets. Okay. There you go. Going very slow. Turns right. Going left now. Try not to hit it. There you go. And starts turning left. So I can actually go very slow. Go very slow to the right. And it starts slowing down and turning. So you can do a lot of tricks with this, you know. Basic experience. Very simple. Of course, the faster you turn, the stronger the electromagnetic force will be. So it should actually go faster. Yep, it starts turning quicker. And then it's going to start like gliding because it's turning, you know, on the water. There you go, to the right. Quite cool. And there you go. So that's a cool experience. Actually shows you a lot what you can do with all that, you know. So yes, you can do it at home. This one is easy. Just do it at home and have fun. Okie dokie. So next we'll go to the programming and then to our robots. Let's go. Okie dokie. So let's get into our program. Just getting in the computer right here. Forgot that I had to get into it. Okay. So where is it? There you go. Oh, what happened? Hey, crazy computer. What? Why isn't it staying there? Okay. There you go. Okay, so that's the video of what's going to happen. So we followed all the instructions, mounted up our robots, and here we go. Okay, so right here we have the number 1. Where is it? Where's the 5.1? Okay, so here it gave us all the instructions, okay, what to do. So it's teaching us now how to make Kitty draw a triangle, okay. So in automation, normally you want like the robot to make a certain action with coordinates, okay, like pick an object, pick this up from here to there, okay, and put it down. So this is how we're going to start to do all that, just by simple tasking it, okay. So it gave us all the instructions, and it wants us to create coordinates with Keddy so that he can actually build a triangle, okay. So here it says what it gave us was when you press space, erase everything. For example, this line right here. Set pen color to blue, which can also be any color that you want, okay. And you actually can choose here, you see, you can just change colors to whatever you want. And then you can set the size of the thickness of the line and the coordinates, okay, so they in order we can make our triangle. So once we press the space key, everything's erased and he builds the triangle again. See, so right there you can see how just how correctly it just does the whole order of coordinates. So if it was a robot arm, I could say pick it on this coordinate and put it down on that coordinate. See, you have to do that in order so that it can do the work very precisely, okay. Then we pass to the second programming, which is oh yes, so it's to do a square with one command and make another shape, okay, with another command, okay, which is a rhombus, okay. Now let's go and fetch that program. We'll actually publish this, okay, later on. Yes, we've already saved that. Save now. Okay, so now we're going to go. That was 5.1. And let's see 5.2, which is the other volume that will be being saved right here. Come on. Okay, there you go. Okay, so now when we press the key D, okay, it's going to set the pen color to green. And let's see what shape it's going to do. And when we press L, it's going to make another shape with the red color. Okay, so D. There you go, we have our rhombus figure. Okay, now that's cool. And now we're going to press L, and we get, of course, that little line because it started there. That you can actually erase because you wouldn't want that. You would want it to erase all, okay. Reset it. And I also had to press like the stop, okay. If I press stop, there you go, okay. And now, okay, so it still gives a little bit there, but I'm sure we can reset that somehow. If we press it twice, then it actually does it correctly. It erases it all, okay. So it's also not like I mean, there must be a reset. It says erase all, but I think it should, there is another command here. I'm just going through the book, so it's not confusing, whoever's going to do this one day. But there is various commands, and I'm sure we have one here that is just stop all, for example. Okay, probably this stop all would do the trick, okay. So then we will try that, or something else. I'll test it out later. So L gives us one coordinate and a completely different command for it to go into a square, and D tells it to go into a rhombus mode. Okay, right there. So that is cool. I mean, you can already imagine doing a lot of stuff with that. Just that is like, we're really going forward with it, okay? And there's so much more to do. I'm actually going to be configuring an automation for this machine, and I'll also share that with you guys if you want on the main channel, which will also be cool. Okay, now let's go to our robot. So we did our whole robot construction, and as you saw on the front page, it is basically a jumping bunny, okay? And it's going to show us how to also generate, you see, through electromagnetic field on this looking like a gearbox, but it's not. It's going to create electromagnetic field to produce voltage for this motor. Here we have the motor, and here we have our generator, okay? And then we can also use a battery. So let's get to it. Okie dokie, so here we got our little cute bunny with the moving eyes. How cool is that? Okie dokie, so we're first going to do our battery supply. This is what we use in all our videos. If you go back and see them all, you should go see them. Okie dokie, so sorry, oops, no problem. Okay, and here we go. So it's going to stop jumping once I switch the switch on. There you go. And now if we go and turn this around, okay, and we get our opposites, negative and positive poles, it is going to go on reverse mode. There you go. So that's with the batteries, okay? We have two AA batteries supplying it, and we can actually go 2 speeds because it uses either one battery or it uses 2 batteries, okay? So if we go full blast, you see it goes much faster. Turn it around, and there you go. Okay, now we're going to do this using Faraday's law by turning it around, okay, using electromagnetic force field, okay, with a coil inside. So by turning this around, you can hear it, we're going to be creating our own, okay, voltage to turn the motor. Let's go. Okay, so it's actually going to go backwards because it's opposites, okay? Here we go. And now I'm going to start turning. See? And the faster I turn it, so just because I don't even have to turn it around here, because by going opposite rotation on my generator, I'm really changing, okay? Positive to negative. Remember seeing that in the previous part of this video? So here we go again. I changed the cable, okay, and now you're going to see. And backwards, see? And there you go, guys. So our other robots. Now this is just going to be going more and more evolved with each volume, each episode. So stay tuned, everyone. Okay, and that's for today. That is all. Oh, look what he did. Okay, and even the little bunny wants to say bye. Okay, so with this, hope you all enjoyed this, and see you all on the next one. And with this, see you all on the next one. Oh, oh, oh. Okay, everyone. So with this, see you all on the next one. And I'm out.